Hello wonderful person, this is Anton, and in this video we're going to be discussing a somewhat strange discovery involving two of the most intriguing worlds in the solar system. The dwarf planet Pluto that you see spinning behind me, and the mysterious moon of Saturn referred to as Titan. And while these two bodies are billions of kilometers apart and occupy very different neighborhoods, in one of the recent studies, astronomers discovered a very peculiar spectral feature that seems to link them together, but more importantly, seems to be coming from something that we've never seen before and something that's basically unknown to modern science. And so here, using the incredible sensitivity of the James Webb Space Telescope, researchers detected a somewhat strange, unidentified substance on the surface of both of these worlds. And so in today's video, we're going to take a look at this discovery, speculate about what the substance might be, and why it matters for our understanding of the solar system, and of course, what this means for astronomy as a whole. But in order for all of this to make sense, let's start with the actual discovery, and with what exactly scientists were able to see. And so here, a team led by Bruno Bizard from the Paris Observatory just published a study that you can find in the description. And here they were looking at the data coming from the James Webb, mostly focusing on two specific instruments, NIRSpec and MIRI, which can see the near-infrared and mid-infrared frequencies. And here they discovered a very specific dip in light that seems to represent a reflection from the surface, on the surface of Titan and on the surface of Pluto. And this type of a dip, when observed on any other object, is called an absorption feature. This is basically the result of something on the surface absorbing some of the light in the specific frequency and basically creating this dip. And so in astronomy, this is usually how we find what certain objects are made out of, and how we find different elements on different types of moons and planets even without visiting them. But in this case, this particular absorption feature was at a very specific wavelength of 5.11 micrometers. In this case representing a dip of about 6 to 7%, with researchers determining that the signal originates from some kind of a solid on both of these celestial bodies. So this was determined not to be the result of atmospheric absorption and has to be something on the surface. And well, here this is important because every known chemical compound usually has its own fingerprint visible in different light spectra. In other words, every molecule known to us, for example carbon dioxide, methane, oxygen, and a lot of other stuff, produce very specific absorption spectra that we can then use to detect them somewhere out there. And so when light hits the surface and some of it is absorbed by these chemicals, it essentially produces something that looks like this. Now this is an example of the atmospheric absorption from Mars, but it essentially tells us that there's quite a lot of carbon dioxide, a little bit of water, and a little bit of carbon monoxide. And the bigger the dip, the more material seems to exist. And so by analyzing different compounds on Earth, and by producing these absorption spectra, we can then match them from observations on other planets, and thus determine what they contain. So here, as you can see, the carbon dioxide absorption matches the absorption produced in the lab, which is of course how we know what seems to be there. And well, for the most part, both Titan and Pluto so far had absorption spectra that were not particularly mysterious. Here we actually have several separate studies, essentially confirming a lot of methane, quite a lot of nitrogen, and even things like carbon monoxide once again. And though at first Titan and Pluto might not actually seem alike, turns out they do have quite a lot of similarities. And so even though Pluto is a frozen dwarf planet in the Kuiper belt, 40 astronomical units away from the Sun, and even though its atmosphere is very thin, actually approximately 15,000 times thinner than Titan's, whereas Titan's atmosphere is even denser than the atmosphere of Earth, with Titan even containing liquids on the surface, so here we're talking about rivers and lakes. Despite of this, they actually do have a lot of similarity in terms of chemical composition. And specifically, the chemistry of their atmospheres is remarkably similar. For both of these worlds, the atmosphere is dominated by nitrogen and methane, although the atmosphere of Titan is a little bit more complex. But because of this nitrogen and methane, both objects also experience something else that many other planets and moons do not experience. Here, when sunlight hits a lot of these gases, it actually triggers very complex chemical reactions that then generate very specific organic haze. haze that's a lot more pronounced on Titan compared to Pluto. But importantly, a lot of this haze eventually starts to freeze and basically snows down onto the surface of each of these worlds. And so on Titan, some of the recent studies suggested that this organic snow could be anywhere between several centimeters to even 1 meter in thickness, actually forming this very fluffy and somewhat soft blanket of snow on top of the water ice crust. In other words, I guess in some sense Titan might resemble a massive snow world in certain locations. And something very similar potentially happens on Pluto, but to a much lesser extent. And so here this shared chemistry is likely why we seem to see the same mystery compound on both surfaces. In other words, the atmospheric chemistry that seems to happen on both Titan and Pluto seems to result in this compound we've never seen before. But what makes this even more interesting is how this substance potentially looks on each of these worlds. And that's because the observations from Titan suggest that this absorption feature seems to be relatively narrow, whereas on Pluto the same feature is about 3 times wider. Which I guess raises the question of, so what's happening here? What does this difference mean and what does it show us? Well, the best explanation right now suggests that this is very likely due to the physical state of the compound. And so, for example, on Pluto, since the surface is exposed to a lot more cosmic rays and cosmic radiation, mostly because the atmosphere is extremely thin, this radiation then breaks the chemical bonds apart and messes with the molecular structure, very likely broadening the spectral signature and thus changing the overall composition. Although alternatively, it could also be the actual size of the grain, or basically the snow that forms might be just different in size and thus results in a slightly different thickness of the absorption. Lastly, this could also be the result of mixture with something else on the surface, which then produces a compound that's a little bit different and thus very likely looks a little bit different as well, containing slightly different texture on the surface. But in terms of the actual color and the overall appearance, they're both basically the same. Although as of right now, as of June of 2026, nobody actually knows exactly what this is, or of course, how it looks. And this is even after researchers compared the signal to thousands of known chemicals in most of the international databases containing ices, hydrocarbons, and complex organics like, for example, tholins, the compounds that make objects like Pluto somewhat red in color. And right now none of them were a perfect match. But they do have a few plausible candidates. The first one is what's known as allenes, a group of organic compounds with a very specific carbon chain containing 3 carbons, as you see right here. And these are actually some of the few organics that seem to absorb light in this specific range. But none of them so far were a perfect match. Then this could also be some kind of a benzene mixture that has been detected in Titan's atmosphere before. And while pure benzene does not really match this, if it's mixed with other molecules, there is a chance that maybe this is what we're seeing. And last but not least, this could also be what's known as a ketene, another organic molecule that shows a very weak signature in this particular wavelength, with the main researcher basically mentioning that whatever this is, it's definitely going to be a surprise once it's identified. Mostly because this is not a simple pure substance, but seems to be some kind of a complex mixture of different organic materials. With I guess one of the last questions being, so okay, why exactly does any of this matter? Well, this is not just about discovering some kind of a weird space snow. And that's because today Titan is one of the most exciting objects where we could potentially discover some kind of a prebiotic chemistry. The kind of chemistry that happened on Earth before life began. And so understanding what these types of solids and molecules seem to be essentially tells us how far chemical complexity can go even on a very cold, icy world. But on top of this, it's also because NASA is actually going to this object really soon with a Dragonfly helicopter that's going to be launching in the next few years. And so in this case, scientists are currently mapping some of the best locations to explore for this mission and are actively using the James Webb's data to map exactly where the substance seems to be located on Titan. And so if it's only in very certain geological areas, it could potentially give us a clue about how it forms, and thus give us a clue about whether this is something we want to explore, or maybe this is a location we should be avoiding especially if the helicopter ends up landing in some kind of a massive amount of snow and gets stuck inside of it. But at the moment, the scientists behind the study are essentially trying to tweak some of the organic mixtures in the lab condition in order to see if they can recreate this 5.11 micrometer signal and thus explain what this potentially is. And so chances are that even before the dragonfly ends up landing here, researchers might find the exact substance that seems to produce this, which will of course give us a little bit more detail about what's happening on Titan and Pluto, and potentially answer the question of if life can exist here. But by mid-2030s, there's a very high chance that as Dragonfly lands here, it can actually use its mass spectrometer to eventually identify all of these mysterious chemicals. But honestly, when you kind of try to put this in a perspective, it's actually kind of mind-blowing what we're able to achieve now with just one single telescope. Or basically by taking just one picture from millions of kilometers away, we can detect very specific organic materials on the moon orbiting Saturn and a dwarf planet even farther away. Something that I think most of us would think would be practically impossible just a few decades ago. But this also shows you that even today, we still have so much to learn about the solar system and about the chemical diversity that seems to be hiding everywhere around us. And so once we get more data, and once we get some conclusions and some answers, we'll come back and discuss this more in some of the future videos. Until then, thank you for watching, subscribe, come back tomorrow to learn something else. Support the channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye. Oh yeah, I forgot. We'll probably have to come up with some kind of a name for this mystery substance, so if you have some cool ideas, drop them in the comments below. Anyway, bye bye.